Okay, as Omar already said, I will talk about the wireless communication that Continental was responsible for in the project. So if I say if the charging is wireless, communication needs to be wireless too, so I think that's clear for everybody. However, when we started the project 3 years ago, nobody took care about communication, especially wireless communication. So therefore we had to start right from the beginning. What does it mean, especially for inductive charging? Because for the other charging technologies, for wired charging technologies, for DC charging, for instance, it was clear and it's already defined and standardized. But for wireless charging, it's still not standardized, and when we started, it was not known at all. So for all the communication procedures, AC charging, DC charging, and also wireless charging, communication is essential. If you do not have communication, there's no public charging possible and available. That's a general rule for all charging. So therefore, you need communication, especially for wireless charging, because where else from should the charging station know that the vehicle is there and ready for charging? Okay, and that's why we proceeded several steps in providing a prototype, and we provided several prototypes. One for the EV, what we call electric vehicle communication controller, which is the short name EVCC. And we also have communication controllers for the charging spot. The charging spot in standardization speaking is SE for supply equipment. So for some reason charging station means supply equipment. So we also have supply equipment communication controllers, SECCs. And we had a complete pair that talk to each other, of course, encrypted, in an encrypted way. And so the first step we had to do is, what kind of data do we need, what the EV needs to tell the charging station, the SE, the supply equipment, and what needs the supply equipment answer to the electric vehicle. And we said it will be vehicle data, it will be general data, it will be user data, so who's in the car, who's approaching, is the person who is coming allowed to charge or not, and all this kind of data. So we collected all the data, including some special new data which are new and which are not used for conductive charging. For instance, positioning data of the vehicle. Is the vehicle well positioned above the ground coil? And is the positioning done and completed, and is therefore the whole system ready for charging? So this is also a quite new topic which is special for inductive charging. So after having all the data, we had to think about how will they fit to very small vehicles like bicycles or scooters, up to buses and so on, because the task was make a communication that fits to all kind of vehicles. So our task was to have an interoperable between all classes of vehicles, an interoperable system. So yeah, we also had to think how long will the communication take, which length of data, and also what repetition of data, and also what resolution of data. And this is one protocol we defined. So this is one ID, one identifier, which is transferred from one side to the other side. And we have a lot of these identifiers. So I will not go to all the details. Just let me draw you to that very first value. This is the current voltage of the vehicle. So both need to know what is the current voltage, what is the maximum voltage, where do we have to stop charging, at which level of voltage, for instance. Therefore, we also need to transfer voltage. And of course, small vehicles have low voltages and big vehicles have high voltages. And we said that especially the big vehicles could have potentially a voltage of 1000 volt, so 1 kilovolt. But in order to be open to future needs and future challenges, we said let's add one more digit. So from 1000 we went to 10,000. So this is, I know, a very high voltage, but maybe we need more than 1000 volts for buses and trams maybe. And so we are still operable at this time. However, the longer the data we transfer and the more often and the more the resolution is, we had to think about, do we still have enough time to transfer all these amount of data? And this is what we also had to take into account when looking at the different protocols we have. So we also had, the requirement, the specification that the distance of the communication needs to exceed 10 meters. 10 meters should be enough for even for a bus, or if you have seen today for this small transport vehicle from Fiat. And we also said we do not want to invent a completely new protocol. We want to base on an existing protocol. So having in mind all the data and the speed and the number and the range and so on, we looked on many existing standardized protocols like Bluetooth, Zigbee or DACT, but finally we decided to use Wi-Fi. Because we think that especially wireless LAN, which is, by the way, also mentioned in the standard that Omar showed before, and also Bluetooth, these two protocols will find their way into each vehicle anyway in the future, and many vehicles already today have these two protocols implemented. So it's relatively easy to extend the Wi-Fi and potentially also the Bluetooth to our needs. Then we said, what do we have to build from hardware point of view? How does this communication fit into the overall system of wireless charging? And together with our colleagues and partners in Unplugged, we did it that way. So we have the vehicle side and the charging spot side, of course. We have control electronics on both sides, on vehicle side and on charging side. And we have these two communication controllers talking to each other, wireless of course, while the power transfer is going that way and from the ground into the vehicle, also here through an air gap, also wireless. But on both sides, of course, they are connected to the overall system, which is the charging station and the vehicle. Yeah, now how does the hardware of the communication controllers look like? And we made it relatively simple. So we said we need to have a gateway. So a gateway that transfers vehicle, in that case, vehicle or charging spot internal data from their data buses they have in their controlling and in their electronics. We need to transfer these data to the Wi-Fi system. So we have a microcontroller, a computer, and we have different bus controllers. So we have different buses that talk to a Wi-Fi router, and the Wi-Fi router is transmitting to the vehicle, from the station to the vehicle. And you see, because we wanted right from the beginning, we wanted to have this very generic, we wanted to have a communication controller that fit to each kind of car, to each kind of environment. Therefore, we support a lot of different buses. A standard Ethernet bus, a USB bus, and also a CAN bus. And in addition, we also have in reserve a very simple analog signal, let me call it also bus, but it's more a simple, very simple protocol that all EVs also use for conductive charging. And the idea is, if these signals are running, we even could use these communication controllers for conductive charging in order to have an additional communication path there. So these are very generic, very general, useful controllers you can use at least for charging and for all kind of vehicles, for interoperable vehicles. Then we also went into software, because we have a communication controller, a microcontroller inside. So we need to handle the different buses, the different protocols, and to push them from one side to the other in both directions, both directional. And we also do this from vehicle to the charging spot and vice versa. And we took all these different data into certain blocks and into certain identifiers. And we did this having a look on the already existing standard for wired charging, for conductive charging. And this standard already gives us these structures, beginning from start of communication process through certificate handling, identification, and so on and so on. And we also did it leaning on this 15.11.8 standard. We also did it with the same naming of the protocols. The only thing that's new is the number of the identifiers. And we also started from the vehicle side to the charging spot and then in bidirectional. So the initiating part is the vehicle, because that's standard. The vehicle is the master in the system. So the vehicle asks the station for a certain service, charging service for instance, and the charging spot answers. So this is why you always find here the REQ at the end, which stands for request. So the car sends a request, and the charging spot, the SE communication controller, answers with an RES, with a response. Okay, because the master is the vehicle and the charging spot is kind of slave, is responding. So this is given from an existing conductive standard, and we made the transfer to wireless charging. And if you look into the development process, the development process is often shown as a so-called V, which is a V cycle, because the idea of that V is that you start from a definition phase, go into depth, and from that technical depth you go back into general topics to the system. And so starting with the requirements on the left side with the general concept, we also had the whole consortium in discussion. Then they handed it more over to software, firmware development and hardware development to Continental. We did the prototypes you see here on the right bottom side, and then again we gave them back for system integration, for vehicle integration, and so on. Yeah, so it was a clear cooperation in that in these steps and in these levels. So if I look back, and this is my last slide now, if I look back what we have done so far, so I can say it was interesting, I think, to all of us. It was new from the very beginning. We also entered a certain level of experience and a know-how increase. I'm sure all the participants didn't have before. So at least I, from Continental and supplier industry point of view, I feel better prepared now for the upcoming market. So we believe the market will come. We also believe that the market, by the way, will depend on a ready standard, and we are close to a ready standard. So once the standard is finished, I think the market also will grow on inductive charging. Charging communication is an important aspect. I already explained it to you. However, it's only one aspect of a general car-to-grid, car-to-car, and whatever kind of communication. So charging communication is just one additional thing. And we also proved that it's possible with the exact same communication to run a small passenger car and also a bigger lorry up to buses and trams with the same communication. And we also at least calculated and investigated in will it be the same for dynamic charging, and especially from communication point of view, I can say there's only very, very little we have to change from static charging to dynamic charging with these communication controllers. Okay, now I'm done. Thank you to you for listening, and thank you also to all our partners that helped us to make this real. Now I'm open for your question.
Thanks. Some question. I started and ask one question myself. I would like to understand from your perspective what is currently the main challenges that the communication, the wireless communication will have to face concerning interoperability from different power classes, different type of vehicles, and different car manufacturers. What would you remark as the main challenges?
Okay. To be honest, it wasn't a real big challenge because the technology that we are based on is relatively good, relatively proven, also fast enough for our requirements. So it was kind of easy to adapt this to our new needs. So, and also all the supplier industry as well as the automotive industry is also has certain experience on these wireless technologies. So yeah, as I said, it was not a big deal to make it. It was more or less just work and kind of mental transfer from conductive charging to inductive charging. And of course the automotive industry today still has more experience on conductive charging than on inductive charging. Yeah, but the level we looked at the conductive charging was relatively high, and the step was not that high.
So if now somebody asks you to have this commercial, how long would it take in terms of time? And can you comment?
Now knowing what we have to expect, it would be relatively easy to bring this into mass production, although we of course only made prototypes. But from these prototype to a mass production start, I think when the standard is ready and done, I think it could take only 2 years to have it available in high volumes.
Okay. Then later we ask Omar when the standard is ready. And
I have to add something. Regard to the cost, what do you think about the expected cost for commercial one?
For communication only? Okay, that's an interesting question. We also deal with that question. What profit, what business is behind that? And unfortunately, from supplier point of view, I say only very little. So I think this communication, talking on for the vehicle only, it's only a price adder of, I don't know, 10, 20 euros only. Also, it's very little.
But for the end consumer point of view, it's good to hear that it's quite cheap.